Why does a 40-ton humpback whale, an animal the size of a city bus, decide to launch its entire massive frame out of the water and crash back down with a thunderous splash? It is one of the most breathtaking sights in the natural world, but from a purely survival standpoint, it seems like a staggering waste of energy. When we talk about this behavior, we use the word breaching, which researchers generally define as when at least 40% of the animal's body clears the water surface. It's not a graceful, dolphin-like leap. It is an exhibition of raw, explosive power. But what exactly is happening beneath the waves before that spectacular exit? And more importantly, why do they do it? To answer this, we have to look at the sheer physics of the move. Breaching represents perhaps the single most expensive burst maneuver found in all of nature. Imagine the effort required to accelerate a body that heavy upwards against gravity and drag until it hits speeds high enough, around 8 to 9 meters per second, to actually exit into the air. For a 15-meter-long humpback, a single full breach can expend as much energy as a 60-kilogram human would during an entire marathon. How can we be so sure about the massive energy cost of these leaps? Recent studies, like the one led by Paulo Segre, utilized high-tech whale-worn tags equipped with inertial sensors and cameras to measure the kinematics of these jumps. By tracking depth, pitch, roll, and the frequency of tail strokes, scientists have determined that breaching pushes the very limits of vertebrate muscle performance. For larger whales, the mass-specific power output required to reach breaching speeds is near the absolute ceiling of what muscle tissue can deliver. If it is so incredibly taxing, could breaching be a form of honest signaling between whales? In the world of animal behavior, a signal is considered honest if it carries a genuine high cost to the individual. By breaching repeatedly, a whale might be saying to its peers or potential mates, "Look at me, I am so physically fit and strong that I can afford to waste this massive amount of energy on a display." It is essentially a billboard for health and genetic fitness. Does the sound of the breach play a role in this communication as well? Absolutely. The ocean is an environment where sound travels much farther than sight. When a whale crashes back into the sea, it creates a massive underwater shockwave and a sound so loud it can be heard for miles. This acoustic signal might help whales keep track of each other during long migrations or serve as a way to establish dominance within a social group without resorting to physical combat. Observations show that breaching often increases when groups of whales merge or split, suggesting it is a vital tool for managing complex social interactions. But is every breach a high-stakes social signal, or could it be something as simple as basic hygiene? Another widely accepted theory is that breaching helps whales dislodge external parasites. Large whales, particularly humpbacks and right whales, carry marine hitchhikers like barnacles and whale lice. The powerful impact of hitting the water surface at high speeds can help shake off these irritants or bring down a layer of skin along with the parasites. Think of it as nature's way of having a good full-body scratch. What about the younger whales? Do they breach for the same reasons as the adults? Interestingly, juvenile whales and calves are some of the most prolific breachers. One juvenile humpback was reported breaching 52 times in just over 4 hours. For these youngsters, breaching might be a form of play, which is critical for development. Play allows them to build necessary muscle tone, coordinate their movements, and practice the skills they will need for survival and migration into adulthood. It may also just be an exuberant display of joy. If breaching is so useful, why don't the largest whales, like the blue whale, do it more often? This is one of the most fascinating parts of the research. It turns out, body length, more than mass, is the primary hindrance to breaching. A blue whale can be over 25 meters long, and Whitehead's model suggests that to clear the water at the same percentage as a humpback, a blue whale would need to reach speeds that might be physically impossible given the hydrodynamic limits of lunate tail propulsion. The muscles of these giants simply may not be able to deliver enough power to sustain the trajectory needed for a full breach. This is likely why rotund species like humpbacks and right whales breach frequently, while the long and slender blue and fin whales almost never do. How do whales actually manage to get enough speed to launch themselves while still underwater? They don't just swim upwards, they use specific underwater trajectories. Using tag data, researchers have identified several shapes: a U-shape, V-shape, J-shape, and I-shaped profile. A U-shape involves horizontal acceleration just below the surface, followed by a rapid upward pitch. A V-shape starts with a descent, an abrupt change of direction, and then a powered ascent. Some whales even use an I-shape where they hold station at depth and then perform a direct vertical acceleration towards the surface. Is breaching the only way whales interact with the surface? Not at all. You might also see tail slapping, or lobtailing, and pectoral fin slapping. Tail slapping produces a loud sound that can signal annoyance, warn of predators, or attract mates. Humpback whales are also famous for peck slapping, using their massive pectoral fins, which can be 1/3 their length, to hit the water surface repeatedly. While these behaviors are less energetically taxing than a full breach, they serve similar communicative and social purposes. Could breaching also be a way for whales to see what's happening above the water? Some researchers suggest a spy breach or head lunge might be used for navigation. While whales have excellent hearing, their underwater vision is limited. By leaping, they might be orienting themselves to landmarks or spotting other whales nearby. This is similar to sky hopping, where a whale lifts its head vertically just to look around. Does breaching align with whales' life cycle? Yes, it is heavily influenced by their life cycle. Many baleen whales, like the southern right whale and humpbacks, migrate from high-latitude feeding grounds to low-latitude breeding grounds in the winter. These breeding grounds are crucial areas for nursing and development. In these grounds, mothers are often in a fasting state, yet they must still transfer enormous amounts of energy to their calves via milk. Even in this energy-depleted state, mother-calf pairs are often seen breaching together. This highlights just how important this behavior must be for social bonding and development, as they are willing to perform it even when energy reserves are at their lowest. What happens if these sensitive breeding areas are disturbed? Because breaching and nursing are so energy-intensive, the sources stress that protecting these habitats from human disturbance, like boat traffic or industrial development, is vital. Any disruption that increases the daily energy expenditure of a mother or calf could directly reduce the energy available for the calf's growth, potentially lowering its chances of surviving the long migration back to the feeding grounds. So, what is the final takeaway on the mystery of the breach? It is clearly a multifaceted tool. Whether it's a whale-sized telegram sent through the water, a way to shake off itchy barnacles, a developmental gym for a growing calf, or an honest display of, "Look how strong I am," breaching is central to the life of a whale. It is a maneuver that pushes the boundaries of biology and physics. The next time you see that 40-ton splash on the horizon, remember that you're not just seeing a jump, you are seeing one of the most expensive and meaningful actions an animal can take in the wild. It is a powerful reminder that in the ocean, sometimes you have to make a big splash to be heard.